Welcome to the Deep Dive. Today we're getting into the really unconventional world of Viktor Schauberger. Think about this. An Austrian forester back in the 1930s, he's looking at a stream, watching a trout just hang there in the current.
Right.
And somehow he comes away thinking he's figured out how to solve, modern energy problems, climate change. The works?
It sounds pretty out there, doesn't it? He was often called a lunatic or maybe a charlatan.
Exactly. But the sources we're looking at suggest maybe he was just seeing things that, well, everyone else was missing.
And that's really our mission for this deep dive, isn't it? To actually explore the source material that details his very radical ideas, nature-based engineering.
Radical is the word. I mean, his work seems to challenge some really fundamental physics.
Oh, absolutely. Especially things like the second law of thermodynamics, the idea that everything just naturally falls apart, tends towards disorder.
Entropy?
Right, entropy. Schauberger was saying, hold on, nature actually uses forces that build things up, that increase order, increase vitality.
Okay, so let's get a handle on the core concept then. It seems to boil down to this shift he talks about. From explosion to implosion. What do those terms mean for him?
Well, think about our technology or civilization. It's mostly powered by explosion, right?
Combustion engines, burning fuel.
Exactly. Heat, things flying outward, centrifugal force. He saw that as fundamentally destructive, leading to decay, waste, disorder.
Okay.
Schauberger wanted the opposite, implosion. That's movement inwards, centripetal force. It cools things down, it builds structure. And he believed it tapped into what he called living energy.
Living energy.
Yeah. So his whole aim was technology that worked with nature, copying its constructive ways.
Okay, so that philosophy is key. And his way of figuring this stuff out was, well, it was pretty unique too. He talked about achieving blindfolded vision. What was that?
Yeah, that phrase sounds a bit mystical, I suppose. But for him, it described a state of really deep, profound observation.
Like meditation.
Sort of. He'd apparently spend hours just watching water flow. He said he'd let his free consciousness kind of detach from his physical senses. And he believed this let his intuition tap into the subtle stuff, the energetic dynamics happening beneath the surface, the patterns that, our logical, analytical minds just completely miss.
And water was central to this.
Absolutely central. He concluded water wasn't just H2O, it was the carrier of life itself, maybe even the source, the origin of consciousness.
Wow. Okay, so that explains his big critique of conventional science then, if we're just looking at the surface.
We make a fundamental mistake.
Oh.
We see the end result, the physical thing, and we think that's the cause.
Right. Mistaking the effect for the cause.
Exactly. We miss the dynamic, the energy, the hidden reality driving it all. He kept saying, nature never moves straight. It's always indirect.
Spirals, vortices.
Always. Look at galaxies, DNA, water going down a drain. It's all spirals, vortices. Inwinding, involuting, as he called it.
And this specific motion, this vortical movement, is always inward, centripetal, and it cools things down.
That was his core observation. It follows what he called a sublime inner law of energetic reciprocities. It's about balance, harmony, building up.
And water itself is the prime example, especially its weird behavior around 4 degrees Celsius.
Ah, yes, the anomaly point. It's so crucial.
Tell us about that. Why is that specific temperature, 39.2 Fahrenheit? Why is that the magic number?
Because that's the point where water is at its absolute densest. It takes up the least space, and crucially, it holds the most energy. It's structured, ordered, vital.
Okay.
And here's the key bit. At +4 degrees C, the oxygen dissolved in the water becomes passive. It binds nicely, beneficially, with carbone elements.
Carbones, you mean like carbon compounds, the building blocks of life.
Precisely. So at +4 degrees C, water is perfectly set up for positive, formative, life-building process.
Okay, so let me see if I've got this. If water is colder than that, or usually warmer than +4 degrees C.
That perfect life-affirming structure is lost. Exactly. If it warms up even a little, the oxygen flips, becomes aggressive, separates from the carbones, breaks the structure down, leads to decay.
That's huge. So even slight warming, like from industrial runoff or just cutting down trees that shade a river.
It fundamentally breaks the water's biological potential. It damages its life-giving quality before it even gets near a treatment plant. That subtle temperature gradient changes everything.
Mind-blowing. And this thinking, it didn't stop at rivers. He applied it to us, to our own bodies. Which brings us to one of his most startling claims about the heart.
Ah, yes, the non-pumping heart.
You said earlier he claimed the heart is not a pump. That just It flies in the face of basic biology, doesn't it?
It absolutely does. He insisted, no, the heart's a regulator. It's a timing device, maybe an impeller, but it's not the main engine driving the blood around.
Wait, hold on. So how does blood move then, if the heart isn't pushing it? Is he saying biology 101 is just wrong?
Well, he argued it's more subtle. Circulation is driven primarily by gradients and structure. First, he pointed to the temperature gradient in the body.
Okay.
Our core is warm, our extremities are cooler. Flow naturally moves from warm to cool, from higher energy to lower. Makes sense.
Okay, I can sort of see that.
What else? Second, the actual shape, the geometry of the blood vessels. He believed they were designed to minimize friction, to encourage flow. And third, the pulse.
Yeah, the heartbeat we feel.
He said that pulsation comes from the periodic meeting and equalization of opposite electrical charges in the heart chambers. Arterial blood carrying oxygen is positively charged, he claimed. Venous blood carrying those carbonutrients is negatively charged. They meet, equalize, create a rhythm.
That completely flips the script. We think the heart pumps, which makes us need to breathe. But he said, what was the quote?
Let me recall. We breathe not because the heart pumps, but that the heart pumps because we breathe.
So the breath, the atmospheric pressure, the charge in the blood itself, that's the real driver.
That's what he seemed to argue. And it ties right back into this idea of implosion.
How so?
He described implosion as this higher inward fall, using that centripetal inward spiraling force to return matter to its basic energy state. Its primary energetic matrix, he called it.
Like tapping into some underlying energy field.
Kind of. Think of it as energy flowing inwards and upwards, creating a sort of perfect vacuum. And he believed this vacuum was a source of immense constructive power. Limitless, almost.
And he wasn't just talking theory here. There's a story about Professor Felix Ehrenhaft.
Right. Ehrenhaft's research apparently suggested these implosive forces could be something like 127 times more powerful than explosive forces.
127 times. And Schauberger built machines based on this.
He did. That spring water device is a prime example. He designed it to use intense suction, that centripetal motion, to make super high-quality distilled water, like mimicking a mountain spring.
And what happened?
Well, according to the accounts, when he fired it up, the vacuum, the suction it created, was so intense that it actually pulled mercury from the seals, and mercury is incredibly dense. Yeah. Pulled it right into the water it was treating.
Wow. So the machine worked too well.
Seems like it. And the story goes that the authorities, the Austrian police, used this mercury contamination as a reason to confiscate and destroy the device.
Imagine that. Your invention works so powerfully using nature's principles that it gets shut down. That says a lot about how disruptive his ideas were.
It really suggests the conventional way of thinking just couldn't grasp, or maybe couldn't handle, the implications of working with these natural forces.
It's staggering. And his challenges didn't stop at earthly engineering. We have to touch on his cosmology, his view of the sun, which is, well, it's pretty mind-bending.
Yeah, this one is really out there. Schauberger held the view that the sun is actually a cold, dark body.
Cold and dark. How does that even work? Where does the light and heat come from then?
He argued they aren't generated by the sun itself. They're born, created when the sun's energy, its shafts, as he put it, interact with the Earth's atmosphere.
So light and heat are phenomena of the atmosphere.
Essentially, yes. Contained within it, reflected back, triggered by the solar emanations. That was his view. Completely upends standard astrophysics.
That's wild. But you mentioned the sources hint he wasn't totally alone in thinking this.
It's fascinating, yeah. Apparently, translations of ancient texts like the Ecological tablets and teachings from Tibetan masters also suggest something similar, that light and heat are properties of the atmosphere, not the sun directly.
That hints at a whole different stream of knowledge, doesn't it? An alternative science or understanding?
It really does. If our atmosphere is the crucible for light and heat, that changes how you think about, well, everything. Physics, maybe even biology and evolution.
Okay, let's bring it back down to Earth, though. Back to his practical engineering, using these flow principles. Those log flumes he designed in the 1920s, they baffle the experts, right?
What baffled them? See, standard flumes couldn't move the really heavy logs, the sinkers, they just get stuck.
So what did Schauberger do differently?
He realized it wasn't just about pushing water downhill. You had to treat the water right, cool it, structure it, make it behave like a natural shaded mountain stream. He put special spiral guides, rifling slats inside the flume walls, like the inside of a gun barrel.
Ah, to make it spin.
Exactly, to create cooling longitudinal vortices, clockwise and anti-clockwise spirals within the main flow.
And this spiraling, this implosive motion,
Mm.
what did it do?
It created suction. It actually pulled the heavy logs along, reducing friction. He was copying how a trout holds its position in a fast current.
Using tiny vortices.
Yeah, tiny vortices from its gills and fins create a counterforce. He applied that principle, and suddenly these impossible logs were moving easily over long distances, using forces the conventional engineers didn't even account for.
Amazing. And he applied the same thinking to whole rivers, didn't he? For flood control and health.
He did. Conventional river management often involves straightening channels, building high banks, making the water go faster.
Which sounds logical, but...
No. But Schauberger showed that natural, meandering rivers have built-in brakes. The curves, the pools, the riffles, they create vortices that slow the water down naturally, preventing it from accelerating out of control and causing destructive floods downstream.
So the solution isn't brute force containment.
No. It's respecting the river's natural dynamics. His research showed river flow, how it carries sediment. Everything depends on tiny temperature shifts and maintaining that cool, healthy state.
So what did he propose? More trees?
Absolutely critical. Shading rivers with trees is paramount. The tree canopy acts like a giant refrigerator, cooling the water, keeping it near that vital +4 degrees C, and using carefully placed flow guides to encourage those beneficial cooling vortices. Work with the river, not against it.
It's all about subtle, natural alignment, which also explains his golden plow, right? Another seemingly small change with big results.
Incredible, isn't it? Just swapping out standard steel plowshares for copper-plated ones.
Why copper?
He argued that iron and steel, through friction, create harmful ferroelectromagnetic effects. They heat the soil, damage its fine capillary structure, kind of burn it on a micro level.
Okay.
Copper, being a different kind of conductor, generated what he called beneficial bioelectromagnetic effects. It worked with the soil's natural energies. And the results?
40% increase in yield, the sources say.
Up to 40% in field trials. Just from changing the plow material, no extra fertilizer, no machines, just respecting the subtle earth energies.
That's phenomenal. Which makes the consequences of ignoring these principles even starker. Let's talk about deforestation. He called it a biological short circuit.
Yeah, a powerful image. When you clear-cut a forest, the bare ground gets baked by the sun. It heats up rapidly.
Right.
So now you have a negative temperature gradient. The ground is much hotter than the rain falling on it.
Like that hot plate analogy you mentioned earlier.
Exactly. Pour cold water on a hot plate. It sizzles, beads up, runs right off. It doesn't soak in.
So floods.
Destructive floods, because the water runs off the surface instead of infiltrating. And just as importantly, you lose that vital groundwater recharge. The water doesn't get back into the earth.
And it's not just clear-cutting, but also monoculture, planting rows of the same tree.
He saw that as almost as bad. Natural forests have incredible biodiversity, different species, different ages, complex root systems, all interacting. Monoculture destroys that supportive matrix, that natural community.
This lack of respect for natural systems, for water's vitality, it extended to how we treat drinking water too, didn't it?
Oh, he was fiercely critical of modern water treatment, chlorination, for instance.
Standard practice everywhere, kills bacteria.
Kills everything, he'd say. Sterilizes the water to death. It kills the beneficial microorganisms, too. And since our blood is mostly water,
90% right.
consuming that dead, sterile water, he argued, actually harms the beneficial life within our own bodies, potentially impairing our immune system over time.
And fluoridation.
He pointed out that the sodium fluoride typically used is basically industrial waste, a byproduct of aluminum smelting. And he linked it, based on studies available even then, to serious health concerns.
Like bone cancer.
Specifically osteosarcoma, yeah, particularly in young males. He saw both chlorination and fluoridation as fundamentally denaturing water, stripping it of its life-giving properties.
And he connected this poor quality, dead water directly to our ability to think clearly, our intellect.
He did, which really brings us to the path forward he envisioned. All his work pointed towards harnessing these natural implosive forces for clean energy, right? Free energy.
Free energy. How did he see that working?
Well, take the deep ocean. You've got abyssal water down there, very cold, dense, low in oxygen, but rich in those carbon elements.
Okay.
This deep water has a natural affinity, a kind of hunger for oxygen near the surface. It wants to rise.
Like the mountain spring in reverse.
Exactly.
Right.
So give that deep, cold water a suitable pipe, one designed with those internal spirals to encourage vertical flow.
And it will rise naturally.
It will rise powerfully, drawn upwards by that natural temperature and density gradient. gradient, and that implosive centripetal force can be harnessed. Turn turbines, generate electricity, clean, limitless power drawn directly from natural gradients.
It sounds almost too good to be true. But we know his work faced constant opposition.
Constantly. Patents blocked, devices confiscated like that water machine. He was ridiculed, discredited.
The sources mentioned this felt like ideological repression, similar to other scientists whose work threatened the status quo.
Yes, he certainly felt that way. Like the French scientist Jacques Benveniste and his water memory research met with fierce opposition. Schauberger believed any knowledge that could potentially collapse existing power structures, especially those based on fossil fuels or purely mechanistic science, would inevitably be suppressed.
Because it required such a fundamental shift in thinking.
A complete reversal, really, which leads perfectly into his famous quote, his summary for how we should approach technology.
The one about doing things the opposite way.
That's the one. People would ask him, how else should it be done then? And his answer was simple, exactly in the opposite way that it is done today.
Huh. You can't get much clearer than that. It really sums up his entire worldview, doesn't it? This vision of life thriving on coolness, on inward motion, on attraction and cooperation.
Instead of heat, pressure, outward force, competition.
Yeah. And what we've really learned today, digging into these sources, is that the critical difference between, say, a healthy planet and a decaying one might lie in these incredibly subtle things. Temperature gradients, the quality of water flow.
Tiny changes with massive consequences. And if you pull back to the really big picture, Schauberger's work sends a clear message. Nature has rules. We can't command her. We can only obey her laws.
And the most urgent law to obey.
Based on his analysis of planetary stability, the absolute top priority, even over developing new energy sources, should be massive global reforestation.
Planting trees.
Planting diverse natural forests. He saw the forest as the primary engine regulating Earth's climate and, crucially, the quality and availability of water. It all comes back to water.
Which brings us to our final thought for you, the listener. It ties his physical science right back to us, to our minds. Schauberger argued that clear, harmonious, intuitive thinking was physically linked to the quality of the brain itself, specifically the fine structure, the resonant windings or convolutions.
Right, the physical structure enabling the thought process.
So, if he's right, if poor quality water, dead water, and maybe even slight chronic overheating of our bodies leads to coarser, less refined structures in the brain, what's the real cost of our modern way of life? Our senseless toil, as he called it.
It's a profound question.
Is the cost just environmental damage, polluted rivers, logged forests?
Yeah.
Or does it go deeper? Is it actually impacting our collective wisdom, our ethics, our very ability to think clearly and solve these problems?
A really sobering thought to end on. The connection between the health of the planet and the health of our own minds.
That was the deep dive. We hope you feel thoroughly informed, maybe a little unsettled, but definitely thinking.